everyone. My name is Juan Martinez. I'm a senior research staff assistant at CISN, or the Center for Integrated Earth Systems Information. And today I'll be talking about a data set we're developing called the Urban Socio-Environmental Vulnerabilities Dataset. Next slide, please. So for today's agenda, I'll introduce what this data set is, what its aim is, the objectives of developing this data set, the overall theoretical framework, just a brief overview of the methodology to put the data set together. And then the purpose of this data set is to synthesize these geospatial results and socioeconomic data for policymaking. Next slide, please. So the objective of this data set is focused on cities or urban centers. The goal is to determine the level and areas of environmental vulnerabilities. So we try to combine data sets of both environmental, satellite-derived data, as well as socioeconomic data such as census or other demographic information. We combine this data to try to provide a data-driven foundation for policymakers, researchers, and urban planners. The reason why we think it's important is because we understand that as more people move into these urban centers, there is a convergence of climate risks and rapid urbanization that demands attention from ourselves, as well as policymakers and leaders. So the way we try to represent this or interpret this is through this data set. It's a globally consistent framework. It's a fishnet of urban climate vulnerability and risk data. And the fishnet is created on a 500-meter grid, and it's representing about 13,000 cities around the world. Next slide, please. The way we conceptualize or the theoretical framework around this data set is kind of described in this graph here. And there's three main parts of this data set, or rather four. The first one on the top left is the just general urban characteristics that we're collecting from a range of sources. But those characteristics include GDP, population density, age demographics, child dependency ratio, locations to major urban centers, and other just, city-specific data. On the second one, we also draw current urban vulnerability, particularly environmental and socioeconomic vulnerabilities. So in the bottom left, you can see some of the environmental vulnerabilities that we are looking at. So for example, we'll be looking at temperature variables, wet bulb temperature data sets. We also look at water scarcity, susceptibility to seasonal riverine flooding. We look at air pollution data sets such as particulate matter 2.5. And so all of these data sets come and are delivered as different unique products. They'll have different resolutions, different purposes. And so what we're currently doing is to process all of these different data sets and kind of harmonize them together into these fishnets. We also included this kind of sub-city socioeconomically vulnerable areas. These areas were determined using open source data such as OpenStreetMap, as well as building footprints from Overture that are available for the public through GitHub. And so this process determined areas that are kind of segmented and isolated from being connected to the rest of the city. And these areas, we consider them socioeconomically vulnerable, and they're currently being validated with other slum mapping or underserved community mapping that is available out there. And then for number three, we also try to look at future climate risks. Since we're talking about the future, these data sets tend to be more coarse or based on projections. But we try to include the same kind of environmental information as we've included in the current vulnerabilities. So we'll be looking at heat as well, water scarcity, cyclones, and the other environmental indicators that I mentioned. Now, this is a lot of information, a lot of data that is put together, but the goal of putting all this data together is to generate some country level and city level results that can be digested by decision makers, by the public, who don't often interact with these spatial data sets. And so on the right side, our goal is to synthesize this data information into a matrix that can show the degree of vulnerability for each city, and then we can summarize that as well for each country. Next slide, please. And so this is just a brief kind of methodology that we're using. As I mentioned, there's a lot of input data sets that are all different. So on the left side, that is kind of the first step, is to get all these data sets that come from different formats and resolutions, and try to make them into comparable dimensions. Once we have those data sets ready in either rastered or any form of spatial information, we perform a zonal statistics or overlay analysis, depending on the input that it is. So this gives us a statistic for each 500-meter grid in all of these 13,000 cities. So depending on the input, we use raster zonal statistics to either get a maximum value of, say, temperature or air quality, or we can also grab an average. It just depends on the methodology and the theoretical framework that was established. Once we have these statistics and overlay analysis, we'll have a value for each input per grid cell. And it'll have an ID. And so the next step would be joining this information into the fishnet by these IDs. Some of these zonal statistics and overlay analyses, they they have some null values, or they're outside of the edge. And so in this part of the process, we are determining what to do with these null values and making sure that everything is at least has a value for all of the units, for all the inputs. And then, of course, at the last step, we use this data to summarize and synthesize the information to determine the degrees of environmental vulnerabilities for cities, and then estimate the potential amount of people in these areas that may be vulnerable to these vulnerabilities. Next slide. And so this is an example of what the spatial data looks like. Then this example, this is the city of Cilacap in Indonesia. And you're seeing here on the left side several different variables or input variables that we have. And the top one is, as I mentioned, the socioeconomic vulnerability segments. Right below that, we have water scarcity and storm surge, and you can see how all of these different areas are classified as either being vulnerable or not. Once these areas are classified based on the framework, we overlay them and compound them to determine how many of these vulnerabilities each area has. And based on those degree of vulnerabilities, we can also estimate how many people are in those areas. So this is important because socioeconomically vulnerable populations are often less able to cope and recover from climate events. And so determining where and what degree of vulnerability they are would help policymakers and emergency response teams to better respond to these environmental vulnerabilities, especially as we see the impacts of climate change becoming more severe and impacting more communities and cities around the world. Next slide, please. And so this is a preview of what the fishnet looks like currently. As I mentioned, we're still working on this. And you can see here, this is a different city, Tegal, Indonesia. And we're looking at four different variables. And these are, the zonal statistics that I was mentioning. These are just initial inputs before they're classified. So you can see here on the left side, the warm spell duration. This is number of days. And you can see how each data set has some sort of resolution or coarseness. And so once all these are combined, we'll determine how many people may be potentially vulnerable to these risks. Next slide, please. And so finally, as I mentioned, the goal is to synthesize this information to in a format that can be used by policymakers and that it makes sense to the public. And so this is kind of an example of a table that was done with previous data that we did from an effort with USAID. So this is just an example. These are not results that are from the current efforts, but this shows you an example of what kind of synthesis we would like to do. On the left side, you could see, the name of the city, how many people, and the potential amount of people that may be vulnerable. As well, on the right side, the degree of vulnerability based on city estimates and the city statistics once all of these data sets are put together. Next slide, please. Thank you so much. I look forward to your questions.